Hi, my name is Christine Evers, and I'm a lecturer in computer science and also the cohort lead for the Mind CDT. I'm here today to talk to you about our cohort activities within the CDT. Now, we strongly believe that training and support for commercialization of research are an important part of developing students within the CDT. And to enable training in this area, we organize an annual 5-day innovation camp that enables our students to reflect on commercial viability of their research and to help them inform their future research directions. The innovation camp takes place every year, and it's designed and led by the students and also attended by all students within the CDT. Now, for cohort 1, the innovation camp was delayed by a year due to COVID, but it will instead take place this summer. And the current plan for the innovation camp this year is to spend 5 days in Edinburgh, during which time Set2 will provide training on entrepreneurship. The innovation camp will also involve a hackathon, and the students will develop an outreach activity that will be delivered to Barton Peveril Sixth Form College later in the year. And of course, there will be plenty of opportunities to explore the city of Edinburgh, for example, to hike up Arthur Seat. The innovation camp will also involve a pitch event, and this is a very exciting opportunity and an opportunity that I'd like to go into in a little bit more detail now. In order to enable our students to actively develop ideas for commercialization, in addition to entrepreneurship training that is provided by Set2, we have set aside 5 awards of £10,000 each. The awards are designed to enable teams of PhD students and their supervisors to access the impact services that are offered by Future Worlds. Future World services include, for example, access to video production and promotion, to matching services, but also to pitching to investors. The awards will be competitively awarded, and to this end, for each innovation camp, we will host a pitch event. During this pitch event, PhD students can pitch their ideas for commercialization to a panel, and awards will then be allocated based on the assessment and feedback that is provided by the panel during the pitch event. So this is a really great and unique opportunity to explore how you could actually commercialize the outputs of your own PhD research. Another important aspect of the Mind CDT is that we strongly believe in the benefits of collaborative research. And to this end, one of our goals is to create an environment that exposes our students to a range of interdisciplinary ideas and many different ways of thinking in order to create connections both between researchers, but also between researchers and stakeholders. And as such, in addition to the support that you would receive from your academic supervisors, you will have regular interactions with our program leader, Tim Norman. You will be assigned a personal academic tutor who will provide guidance and pastoral support. You will have a student member from a previous Minds cohort who will share their experiences with you, and you will receive support from our CDT manager, Emma Miles. Meeting-wise, we host weekly informal catch-ups between the cohorts, as well as monthly meetings involving all students and the CDT management. From a management perspective, the CDT is led by our internal management committee, and it's guided by an advisory board of external stakeholders. And for both meetings, so both the management committee meetings and the advisory board meeting, they involve representatives from the student cohorts. One of the aspects that makes the Mind CDT very different from a traditional PhD program is that the project selection is actually student-led. Some of our students find their ideal match ahead of applying for the PhD. For example, through externally advertised projects that are advertised by supervisors through the CDT. And those students would apply directly for projects with a specific supervisor. But many students apply to the CDT with a sort of initial project idea, but have not actually established connections to academic supervisors yet. So to help students select their projects and their supervisory team, we as a CDT help you establish links to potential supervisors and industry partners. So to this end, within the first few weeks of the semester, we host a pitch event where academic supervisors pitch their own project ideas to students. And this event also involves industry partners and is therefore a sort of matchmaking event that brings together our students, academics, and industry partners and helps everyone to identify common research interests and from there develop a project together that is shaped by the interests of our students. Now, naturally, the CDT is highly interdisciplinary, with students coming from backgrounds across, for example, computer science, engineering, mathematics, and physics. So to ensure that you can hit the ground running for your research whilst you're really playing to your own strengths and your own background, the Minds iPhD program is a 4-year program where the first year consists of taught modules and the remaining 3 years then correspond to your research phase that is dedicated to your research project. The first year, so the taught modules, provides you with a set of modules that are actually tailored to complement your specific background and equip you with the knowledge that is required for your research project. In each of the 2 semesters, you will select 2 core modules that are compulsory, and then you will select 2 additional optional modules from our master's programs in computer science and electronics. The core modules provide you with a training that enables you to develop research questions, to understand and ensure impact of research, and to work jointly on group research projects and therefore collaborate. The optional modules are selected by you to best complement your existing skills and to facilitate your research project. Now, my final slides are going to provide some examples of current projects that are ongoing within the CDT. Mark Towers is working on neurosymbolic methods for explainable reinforcement learning with Tim Norman, Chris Freeman, and Yali Du. Mark joined the CDT with a BSc in computer science, and he will develop novel algorithms that enable human understanding of learned policies. In other words, the aim of Mark's project is to enable intelligent agents to explain their decisions that are grounded on learned behaviors. To achieve this aim, Mark will combine neural networks with symbolic representations, and Mark's project is affiliated with the trustworthy Autonomous Systems Hub, which is a £12 million national strategic investment that is led at the University of Southampton. And the project will be conducted in collaboration with Thales as an industry partner. Katerina Spandati is working with Themis Prodromakis, Kushik Maharatna, and Alex Serb on hardware accelerators for neuromorphic sensing. Katerina has joined us with an MEng in electrical and electronic engineering, and the aim of her project is to design novel AI hardware that enables ultra-low power sensing modules. So to achieve this aim, Katerina will investigate handling spiking inputs from neuromorphic sensors such as silicon retinas or e-nosers. And Katerina's project is conducted in collaboration with Roke. Yang Wang is working on deep source separation for machine hearing with Phil Nelson and myself. Yang has joined the CDT with an MEng in acoustical engineering, and he's interested in solving the so-called cocktail party problem. So how can a listener distinguish between multiple competing sound events in complex scenes such as restaurants or public spaces? To achieve this aim, Yang is designing novel acoustic features that are used as inputs to neural networks and that mimic the human auditory process. Maddie Dwyer is working on machine learning based on-chip detection of security attacks with Basil Halak and Gopal Ramcharan. Maddie joined us with a master's in physics, and she's interested in embedded machine learning for the detection of cyber attacks and hardware tampering. So to achieve the aim of her project, Maddie will investigate reduced precision neural networks that actually enable power-efficient detection of attacks. Maddie's work is conducted in collaboration with the ARM ECS Research Centre. And last but not least, Matthew Durrant joined us with a BSc in mathematics. He's working on game theory for optimization and specifically within the context of reducing carbon emission in shipping. Matthew's supervisory team are Enrico Gerding, Dominic Hudson, and Gopal Ramchan, and the project is conducted in collaboration with Shell and is affiliated with the Centre for Maritime Futures. Matthew will investigate how game theoretic models can be exploited to incentivize more efficient behaviors at scale in order to optimize shipping fleet behavior. A question that is probably on your mind is, what is the impact of COVID-19 on the program at the moment? To this end, the question could be asked, how has teaching been affected this year? All students are given high-spec laptops as normal. We did have some face-to-face teaching in semester 1, whilst the remainder of our modules were conducted in a virtual setting. For all of those on campus, all students and staff had weekly COVID-19 tests, and all our modules were supported virtually through Microsoft Teams. So all lectures that were face-to-face were simultaneously recorded and put online so that students who had to attend remotely could attend, and all other modules were enabled through online virtual access. There was limited access to laboratories, libraries, etc., and equipment loans were available as necessary. The next question could be, what is the financial impact of COVID-19 on CDT funding? We already have funding in place from the UK government. So the funding of the CDT is not affected by COVID-19 because that funding is already in place. And what about experimental research, for example, access to clean rooms? There are measures in place to enable essential experimental research on campus. So to summarize, the Mind CDT is a high-profile centre that is aligned with the UK industrial strategy. Students within the Mind CDT have the opportunity to engage and collaborate with a large number of industry partners and stakeholders. For example, and you see a nice collection of stakeholders and partners on the right-hand side there. For example, NXP, IBM, or Intel. And our links to the industry open up opportunities for you, for example, internships with industry or the government. Students receive an enhanced stipend of £18,560. That is the 2021-2022 rate. All students are based in a dedicated lab on campus and are provided with unique research training that is tailored to your specific research interests. Projects within the Mind CDT are supervised by experts from across AI and engineering, and crucially, the projects are student-led and designed around you. Thank you very much for your attention. At this point, I will hand over to my colleague, Rina. So thank you very much again.